Morning, students. In this video, we'll see about this CANopen. So, CANopen basics of CANopen concepts. So, in that first, we'll be seeing about this CANopen object dictionary. So, this object dictionary is like a table that holds all the network accessible data, and each CANopen node must implement its own object dictionary. So it is basically a table. It is something like a lookup table. So the object dictionary contains a description of the CANopen configuration and functionality of the node it is storing, and may be read and written to by other CANopen nodes. By writing the data to the entries in the OD of a node, the node can be instructed to perform an operation of some kind. For example, sampling the current temperature or the G forces and making the sampled data present in the object dictionary so that the other nodes will read it. So by reading the entries in the OD of a node, other nodes may find out some information about what the nodes does and how it operates. For example, this object dictionary example. So in implementing CANopen network of a node may be responsible for controlling the motors or actuators. So the OD of the node can contain the current position of motors, allowing it to be read by any other node on the network. In addition, other nodes on the network are able to write the new positions to the object dictionary of the node, thereby causing the node to make the motors move as required. So this object dictionary is organized as a collection of entries rather like a table. So each entry has a number called as index, which is used to access the entry. The index is 16 bits in size, giving a maximum of 65,536 entries. Each entry on the object dictionary may have up to 256 sub-entries referenced using an 8-bit value called the subindex. So each entry has at least one sub-entry. Not all the entries in the object dictionary are implemented or used. So this is the structure of this. So this is the organization of this object dictionary. So that is from 000 it is reserved, 001 to 0FFF data types. So again in 1000 to 1FFF communication entries, 2000 to 5FFF in this address manufacturer specific entries, 6000 to 9FFF it's a device profile parameters, and the rest is reserved. So this object dictionary, that is entries in the 001 to 0FFF, it is data types. It is meant for the data types section. Do not store any variables. They are used only for the definition of the data types. So if physically implemented in a node, reading these entries returns the data size of that data type in bytes, or an error if the data type is not used in the node. So this is your data type storage in the object dictionary from 001 to 0FFF. Again, it is organized what type of data. So that is data type storage. So 001 to 001F standard data types. 20 to 23 predefined complex data types. 0024 to 3F it is reserved. 40 to 5F manufacturer complex data types. 60 to 7F device profile standard data types. 80 to 9F device profile complex data types. So, and A0 to 25F multiple device modules data type. So again in this standard data type 001 to 001F standard data type, again it is classified from 00 that is 1, it is boolean type. 0010 means 24-bit signed integer. So like that it is again classified. So data types consisting of multiple bytes, they are transferred using little endian format, which specifies that the least significant byte of the value is stored or transferred first, and the most significant byte is stored or transferred last. So it's in the little endian format. So this is an example for the that is standard data type, and this is an example for the complex data type. So that is complex data type. So it consists of undefined integer, that is error number, and a visible string, that is error text. So the next thing will be the communication entries. The communication entries in the OD describe most of the aspects of the CANopen communications used by the node. Many of the entries or it can be made writable, allowing the configuration by node by other nodes on the network. The entries occupy the index range of 1000 to 1 triple F in the object dictionary table. So mandatory entries are those that must be implemented in a node in order to be CANopen compliant. So this is your CAN communication entry overview. So 1000, that is device type, 1001 error register, 1005 COB ID. So again this is your communication entries overview. So device type, so it is a 32-bit value that describes a limited way some of the capabilities in the node. So error register, it is an 8-bit. So the error register address, it is 1001. So it is an 8-bit value that can indicate if various generic errors have occurred in the node. For example, current error or a temperature error. So guard time, the nodes must support either hot bits or node guarding, both the mechanisms, that is mainly for the network management. So lifetime factor is an 8-bit value that works with the guard time. So producer hot bit time, it must implement the hot bits. So whether a node it is live or enabled or disabled, you can able to see. So identity object provides identifying information about the node. So the next one will be manufacturer specific data, that is entries, or this operation specific, that is entries. So here in this, the node feature, that is indexes from 2000 to 5FFF. So it is left completely open by the CANopen specification for specific applications manufacturer. So that is address range, it will be from 2000 to 5FFF. So for example, in the index 2000, again we can write that is your sub-index, that is we can feature a real-time clock. So we can make the current time available in the OD entry. So device profile parameters, so it provides a variety of that is communication services. A device profile specifies so the process data variables, a node knows, and the default configuration and communication settings. So that is your device profile, one of the example for this device profile parameter. So that is specific, that is reading the CANopen specification. So these are all the, that is object dictionary and this data. Thank you for watching this video.